Good morning, all of you. In the last period, we have studied about in statistical mechanics different types of probabilities. After that, also we have studied phase and macro canonical distribution and canonical distribution. Also, we are going to study here. Then microstate and macrostate. In the last lecture, we have studied. Now, today's lecture we have to study about a division of compartment into the cell. Division of compartment into the cell means what? We have a two compartment. Let us see here. This is the first compartment and this one is what? Second compartment. Now, in the first compartment, what we have to say that we have a k number of cells. This is the compartment number 1. And that can be distributed like compartment number 1, compartment number 2, 3, 4, 5, 6, then 7, k minus 1 and up to k. Means we have up to k number of compartment we have to consider here. Now, we distribute a particle, that is say first n number of particles we have. In that, we have to distribute these particles in the compartment. At that time, it may be falls in compartment number say 1, 2, 3, 4, 5 or 6, whatever may be. And from this compartment, we have to consider to divide a subcell. Now, this is a compartment number 1. We have to distribute, that is cells number say G number of cells. That is, this is what G1 cell. Equally distributed the first compartment into large number of small size of cells, that is G1, G2, G3. First is what? G1, second is G2, third is G3, fourth is G4 and fifth is what? G5 and after that G6. Then k minus 1 is what? Gk minus 1 and last one is what? Gk. In this way, we have to distribute these particles in the cell. Now what will happen that is each compartment is divided into a very large number of subcells, and sub compartment is called as what? Cell. This is a subcell and that compartment is called as what? Cell. Then we have to consider a total number of cells of a same size, that is G1 plus G2 plus G3 Gi Gk is equals to what? G. Now, total number of ways in which two particles can be arranged in a G1 cell is in a compartment number say 1 is given by say G1 into G2. First particle is what we have to consider say G1. Second one also another particle we have to fall in, that is also G1. Now G1 into G1 is gets what? G1 square. Then total number of ways in which n1 particles can be distributed in G1 compartment, means we have a n number of particles and that can be distributed n number of particles can be distributed in G1 cell. G1 cell compartment is, we have to fall the first particle is considered as say G1. Another one more particle can be fall in same cell, that is G1. Then also G1 G1 n times. N number of particles, they can be fall into the G1 cell or G2 cell or G3 cell or whatever may be. We have to consider that n number of particles can be fall in the cell number 1 and that is called as what? G1. And how many particles can be fall in that cell? I don't know. We have to consider that n number of particles, and so we have to write that its total number of n number of particles can be falls in the G1 cell. This can be written as G1 raised to n1. G1 raised to n1. Then total number of ways in which n1 particle can be chosen out in n particle, that is we have to consider a permutation and a combination. In that way we have to distribute these particles, that is permutation and combination. We have to know that NPR. Also we have to NCR. This is called as what? Permutation, and this one is called as what? Combination. This can be expressed in that way. That is what we have to say that NCR is equals to n factorial upon r factorial into bracket, n minus r factorial. Like that we have to write that nc n1 is equals to n factorial upon n1 factorial into bracket n minus n1 factorial. This is the case we have to consider for a n1 particle in G1 cells. Then n1 particles in G1 cell, we have to consider n factorial upon n1 factorial into bracket n minus n1 factorial into G1 raised to n1. This is the case we have to consider for the particle distribution in the first cell. That is, we have to consider a G1, and particles are what? N number of particles. They can be distributed in the first cell. We have to write in this way. That is NCR into G1 N1, G1 raised to N1. This is the case we have to consider for N1 particles can be distributed in the which cell? That is G1 cell. Equally distributed here. After that, similarly we have to consider N2 particle. Now N2 particle, it can be falls in the what cell? Cell number say 2, and that is called considered as what? G2. G2 is also divided into subcells, and here we have to write that N1 can be fall in first one, so we have to consider N minus N1, N minus N1 particles, and that is for first cell N factorial. Here we have to write that N minus N1 factorial into here N1 की जगह क्या आएगा? N2 factorial into bracket. First one is what? N minus N1 minus N2 factorial into, here we have to write that G2 raised to N2. This is for second particle. How will we write that for third particle? Again we have to write for third particle, that is N minus N1 into N1 minus N2 factorial divided by, here we have to consider say N3 factorial for third particle. Again we have to write the N minus N1, N minus N2 and N minus N3 and factorial into G3 raised to N2. Like that we have to write for a k number of cells. This can be written, that is G1, G2, G3, G4 dot, that is k number of cells. We have to write for N1 and N2, combine it. What will happen? N factorial upon N1 factorial in bracket N minus N1 factorial into G1 raised to N1. This is for first cell, that is G1 and N1 number of particles. For cell G2, N2 number of particles. How can we write? That is second particle taken as it is here, N minus N1 divided by N2 factorial into bracket N minus N1 minus N2 into G2 raised to N2. This is the for first particle. This is for first cell, and this is for second cell. Similarly, we have to write for N number of cell or K number of cell. Thus, total number of ways for N particle in K cell can be written as, this is we have how many cells we have, K number of cell, and how many particles, N number of particles. They can be distributed in these cells. This can be expressed as W N1 comma N2 comma N3 dot Nk is equals to N factorial upon N1 factorial into N2 factorial into N3 factorial into N4 factorial up to last one is what? Nk factorial into what are the cells? First one is G1 raised to N1, second one is G2 raised to N2, third one is Gk raised to Nk. This is the way we have to distribute all the particles in the probability form. That is W is equals to, we have to consider N1 N2 dot Nk, or this can be written in a compact form, that is W is equals to N1 factorial into this is the symbol for like that summation we have to write in mathematics, like that here pi symbol can be used, that is I is equals to 1 to K. This is one more symbol used for the writing the distribution or division of the cell, and that is I is equals to 1 to K and Gi raised to Ni divided by Ni factorial. This is called as what? A division of compartment of cell for division of N particle in K number of cell. This can be distributed in this way. Very simple article. We have considered a two compartment. We have considered a compartment, one big compartment. In that we have small number of compartment, that is N number of particles. we have to consider k number of compartment, n number of particle, k number of compartment, and this k number of compartment can be divided into the small cells, that is G1. First compartment is divided into subcell, that is first one is considered as G1. For second compartment it is considered as G2, third compartment G3, fourth compartment G4, fifth compartment G5, sixth compartment G6, and last one is what we have to consider Gk, and this can be distributed, that is in this way. First condition is, remember for that, total number of cells of each, total number of cell each of same size. How many number of cells we have? K number of same size cell we have to consider, that is G1, G2, G3, G1 plus G2 plus G3 plus Gi dot 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 Gk, that is equals to say capital G. Capital G is the whole number of cells we have to consider. And when first particle is fall in the cell number say 1, the total number of ways in which particle can be arranged, that is G1 into G2, that is G1 square. Like that for n particle we have to write that G1 raised to n1 for first cell. Similarly we have to write for second G2 raised to n2, and this can be written for the n particle, that is NCR, that is combination can be written as NCR is equals to n factorial upon n1 factorial into bracket n minus n1 factorial, and this can be n1 particle can be distributed in G1 cell. This can be written by this formula, that is n factorial upon n1 factorial into bracket n minus n1 factorial up to G1 raised to n1. Similarly for second particle, then combine first and second. Then also we have to combine for n number of particle, that is the thus total number of ways of the n cell can be distributed into n1 into n2 dot 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 nk is equals to n factorial upon n1 factorial, n2 factorial dot 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 nk factorial multiply by G1 raised to n1, G2 raised to n2, then gk raised to n1, gk raised to nk, and finally this can be written symbolically form, that is w is equals to n factorial into summation symbol, that is considered as I is equals to 1 to k gi raised to ni divided by ni factorial. This is called as what? Division of the compartment into cell. I think we have to understand. I hope we have to write all these things are very important. Write down. Thank you.